Yeah, somehow we have done it. We are now in the final section. And the final section is concerned with evaluating the fine-tuned LLM that we have just fine-tuned. So here we are in step 9, scoring the responses. In the previous section, we saved the responses. Now we are going to evaluate them systematically with another tool. And so in specific, this will be another LLM. We will be tasking an LLM to take a look at our responses and to give us a score for each of the answers. And this is like one popular way of evaluating LLMs. So there are different ways we can evaluate LLMs, maybe a topic for a future resource on model evaluation. One of them is using another LLM to score the responses. And so for this LLM, we will be using a tool called Ollama. So Ollama is one of my most favorite open source libraries. It's like one really nice and simple way to run LLMs locally on your computer. So it's an open source library, and even though it's called Ollama, which is likely inspired by the Llama models, it also supports other models like DeepSeek R1, Phi-4, Gemma, and many, many others. So they are keeping this model or this code up to date to also always support the latest models. So yeah, and the first step would be, of course, installing Llama. I would suggest going here to the download section. So the website is ollama.com, going to download, and then for your operating system, selecting the respective one. I'm running this on a macOS computer, so I'm downloading this, and it's just wait a few seconds until this is downloaded, and then I'm moving this here to my applications. If you're running this on a different computer, of course, this might work differently. So here we can start it like this. And it will then give us some instructions how to, so we want to install it so that it works on the command line. Click install. I'll type my password for this computer. And then, we can run the model like shown here. So by default, this will run the Llama 3.2 model. Actually, there are multiple Llama 3.2 models. If I go here, it's like a list of all the models they support. If I scroll down to Llama 3.2, this is the 3 billion model. If I run this command, of course, I'm just using this because it's suggested, but the first choice, but you can use any of those models. Usually the bigger and the newer the model, the better. For example, these would be, of course, more accurate, the Llama 3.3, the 7B or 405B model, but chances are that you might not be able to run it on your computer. The 3 billion model is actually quite nice. It's a relatively small model that will hopefully work on this computer for sure. So let me make a new terminal here, and then I can enter Ollama run Llama 3.2, and this will first download the model. I already had it downloaded on my computer. Once it's downloaded, it will then run it. And so I can then ask questions like, what is your favorite ice cream flavor, for example? And then hopefully this generates a response, and so we can see this model is working. Let's exit this model. So by is exiting this model, and we will use this model in ollama.surf mode. So it's cut off in this recording, I think, but if you have in your menu bar this Ollama icon, when you run Ollama surf, I think this will say something like this. So this means your model is already likely running, in my case, on this Mac computer. Let me quit this in my menu bar. So I'm showing you one way we can run the Ollama model in the background, that it is ready. So right now it's essentially running, and then we can use it as the API. It was not necessary to execute it like this if the app was already running on my Mac computer, but it might be different on Linux and Windows. So that's usually how I start Ollama. Instead of going here to applications and launching the app, I usually just type Ollama surf, and this will make the Ollama app available in the background so that we can now query the model with an API interface. So we can see how much RAM is available. I think that's what it means, and so forth. So I'm running this on a very small computer. If you have a bit bigger and better computer, I encourage you also to explore using bigger and better models. And let me also, so I would highly recommend shutting down this kernel here of this current notebook, because you already had this 355 million parameter model in your memory. So this will save some memory. You can then run everything down here, or optionally, you can also make a new notebook. So it's maybe better to keep it more separate. So here, I'm first running some code to just make sure Ollama is running. And, this is just boilerplate code. So it's just printing out whether the Ollama app is running or this surf here is running. So just very simple boilerplate code. And next, so if I'm running this on a new notebook, I'm just loading the JSON file. So this is the file we have just generated in the previous section. So we have this instruction data with our responses. So here we have the instruction, the input, the output, and the model response. That's the modified JSON file. I unfortunately can't make this, I can make it wider like this. So this is this file, and we are just loading it here and into our Python session. And I'm also redefining the format input function. This is the same function we had here, but since I'm using a new notebook, I'm redefining it here. And then I will, it's a lot of code, just copy it here and then explain it. So then I will have some code for querying the Llama model. But by default, so here you can also use Llama 3.2 like the one we used before. So here we provide a prompt. This would be the prompt generated by our format instruction function. We define which model we want to use. So this has to be a model that is available here in Ollama. So when you go here, like I said before, you can find a list of all the types of models you might be interested in. So here, this would be Llama 3.2, the 3 billion model. If you want to use the 1 billion model, you have to append colon 1b. And then this is, these are just some settings. So we have the model, and this is like an API interface to Ollama now. So we have the model, we have the messages field where we provide the prompt as input, and then we set a random seed, the temperature for the sampling to reduce randomness, and then the context size. So here we use 2048. We prepare the payload for this API. And then we create a request here. And then we add this header. So this is all very boilerplate code. This is something I got from the Ollama documentation. So if you are curious where this is coming from, this is basically how you interact with the Ollama app with an API interface. I think it's kind of almost like similar to using the ChatGPT API, if you are familiar with that. So I have my response data. I add my message and content and return the response data. So here, this is essentially what the model would respond to us. So what you are seeing here, this one, if we use our 3.2 model, and what did we ask it before? We said, what is your favorite ice cream flavor? So all I'm doing here is I'm interacting with the model in this Jupyter notebook instead of the command line. The reason why I'm doing this is, so if I have it set up like this, I can ask it to evaluate my responses, right? So here now I have this interface instead of using it on the command line in Python, so I can iterate over my JSON contents, my test data, and ask it to evaluate. So how do we do that? And so I have prepared a prompt here. And so I just did some trial and error, and you might want to improve this prompt. But so what it does, it's like given the input, and so this would be the formatted input entry, and the correct output. So this would be the response field. I'm saying, or I'm asking the Llama 3.2 model, score the model response. So the response that our model generated. So if we go here and we look at one of the results, we have the output, right? And then the model response. So on a scale from 0 to 100, where 100 is the best score, score my response or my model response. So let's see how it performs on 3 examples and see if this is roughly doing something useful. So it might take a few seconds. And by the way, this is just a very simple and short prompt. A user actually recommended, who tried a lot of different prompts, recommended a better prompt. So I will have it here and we'll share it with you in a few moments. But let's look at some of the results. So we can see for the dataset response, the car is as fast as lightning. The car is as fast as a bullet. This score is 100 because it is essentially a correct response to say this. So what is it saying? The model response, the car is close but not perfect, and so and so. But it's still giving it a pretty good score of 100. Here, this one is only a 20 because the answer is wrong. And in this case, it's giving it a 100 because the model response is Jane Austen is correct, basically. So it's giving it a 100 out of 100. So yeah, this is one way, instead of us humans looking at all these inputs and outputs or the model responses and the targets, it's one way to get some number out of it. So now the problem with that is it's not perfect. It really depends on what model you choose here. This 3B model is not very strong. It's a very small model still. So it won't be, 100% accurate. It is relatively simplistic. So don't expect miracles from a small model like that. But I think this is a nice model to just show the idea behind this method. Yeah, little insertion here. I wanted to highlight also one great reader contribution. I just remembered there was one reader who provided a good analysis if you go to the GitHub repository and discussions. So a reader provided good analysis of the quality of the evaluations and also suggested a better prompt template. So I recommend checking out this discussion thread here. So here the reader did really an amazing job checking out different prompts and everything. And then finally provided a better prompt for evaluating the responses. So this includes a rubric that gives the model a bit more structure in the response evaluation. And then also, instead of using a scale from 0 to 100, it's just using a scale from 1 to 5. And this helps a bit with the consistency. But personally, instead of, or in general, in addition to just improving the prompt template, I would say the best bang for the buck is also just to use a better model. So in the Olama repository, we can see there are multiple different models. We were only working with this very small 3 billion parameter model. So as a rule of thumb, the bigger the models, usually the better. They are more capable. They give better evaluations also and better, they have better capabilities to analyze the inputs. Also, as a rule of thumb, newer models also tend to do better. So for example, something like DeepSeek R1. So especially the larger models, if you can run them on your computer. As bonus material, this is also very popular, is to run or use OpenAI to evaluate models. So in fact, there are specific models that have been developed to develop other models. One is Fudge. The other ones, I forgot the names. I think Prometheus is one. But I remember reading the papers, and essentially what they did is they used OpenAI, I forgot which models, I think GPT-4o, and created these scores. And then they fine-tuned another open weight LLM to match those scores. And the goal was essentially replicating GPT-4o behavior. But you could also just directly, for example, directly train, not train, but use GPT-4o. So I do have some bonus material in the chapter 7 folder where you go to model evaluation, and then here I have some instructions on how to use the Open AI API. And so this, of course, would not be free. This would cost some money because there's a usage cost that comes with it, like I mentioned. But this would be the canonical way how people evaluate models. But back to this one, like I mentioned, check out, if you want to, the different prompt suggestion by the user to get more stable responses here. This is honestly just a very simple approach. using a simple model with a simple prompt just to keep things simple and conceptual. So please don't expect miracles from this small model. But yeah, I wanted to show you how this in theory can be used. So here it's a slightly modified version. So we are generating the model scores using a prompt similar to this one. The modification is that we are now iterating over the whole test set instead of only the 3 responses. And here you may notice that the model generates a whole long response. So I'm adding, what I'm adding is essentially a little addition that says respond with the integer number only. So if I go up again, let me just add this here. So the model will then only give us the integer number. And you can see actually the response has changed, I think, to before the scores have changed. So they're not super stable, right? So it's small model. And also, honestly, sometimes I find that depending on the Ollama version, even though I set a random seed and the temperature to 0, I still sometimes get non-deterministic results. So if I run this again, sometimes I get different results. Now it seems like they fixed it in the recent version. So yeah, so this is stable now. So you can see we get a score here, a lower score here because the answer is incorrect, and then almost a perfect score here. It's not perfect, but it is still useful if we have a good model that can evaluate other models to get a rough ballpark number. And so that when we tune hyperparameters, we can see if it's improving the model or not. So here, what I'm doing is I'm applying this to all the 110 entries. And then I'm computing the average score. So here, this is generating the scores. And then, sorry, I'm just looking at this one. The models contain the error. Okay, so yeah, sometimes the model, even though I have this request, respond with the integer only, sometimes it will still respond in a, oh, I've deleted this. It will still sometimes give us the long response, and then of course it's not a number. So in this case, it will fail when we convert here, could not convert score. It will fail when we try to convert it as an integer. So that is what we are seeing here. Sometimes it's still providing this long response, but I'm hoping that for most cases it will give us a number. And then when we have these numbers, what we can do is we can compute the accuracy or the average score. So this is not like the accuracy as we have seen in chapter 6. In chapter 6, it was purely based on whether the model was creating a correct response or not. Here, it is just summing the scores and dividing by the length of the scores. That's how many numbers we have. And so this will be a number, the average score will be a number between 0 and 100. So yeah, so that is what we are looking at here when we get the results. Like I said before, it is a bit flawed. It's not perfect. It's just a bit more automated than having us reading the answers and us judging the model when we do hyperparameter tune the model. But this is also almost like how the real world works. We have these benchmarks for LLMs. There are different benchmarks, like MMLU is the benchmark that is just a multiple choice question answering, which is not super useful because usually when we have an LLM, we want the LLM to write actual text. And so this is one, I would say, one of the most frequently used ways to evaluate models by using another model or a human team to assign scores. So in this case, we get an average score of 51.6. 96 out of 110 answers could be scored. Some of them, as we see here, so it should be 14 answers. 14 could not be scored, which is a bummer, but that's what it is because it's not a perfect prompt. We get a score. What does the score tell us is that the model is not great, but it is okay. Maybe because we see it does sometimes give good responses. So as an encouragement to the readers, maybe try to use the different prompt here, the one I recommended from this discussion board. This might be something to try out and see if it gives you, stable results. And then more interestingly, also when you fine tune the model, for example, when you go through the exercises to compare the model quality before and after the fine tuning, see how much better it does after the fine-tuning. And then also, it would be interesting to try, if you can, some of these larger evaluation models. So there's a lot of stuff that you can still try out. So it's maybe the last section here, but it's not the end of LLM fine-tuning. There are many more interesting things. One other interesting thing I mentioned was in the bonus material, the DPO notebook here, the direct preference optimization, which will additionally choose preferred answers. And yeah, with that, I hope you found these videos useful. I hope they were a bit illustrating how LLMs work under the hood, how techniques work. Again, I must highlight that this is only a very small LLM. It's very limited. It's in a sense, like I mentioned before, when we are curious about how cars work, we are not building a Ferrari, we are building an older, simpler car to understand how the motor works, because for these new Ferraris, you need a whole team, millions of dollars. In the same sense, not real LLMs, this is a real LLM, but bigger LLMs like ChatGPT cost millions of dollars to train, so that we are not doing it here. But I still hope this gave you a glimpse into the world of LLMs, and I hope, you do interesting, cool work with LLMs in the future. Maybe if you have a cool project, post it on the forum. There's also this discussion board here where readers post interesting, cool project ideas in the show and tell section. So you have also like some cool reader projects. People worked a lot on low resource languages, for example. There's a lot of stuff you can do with small LLMs that is interesting. And so with that, have fun and happy tinkering.
Get this book at Manning.com.